All right, today we're going to be learning about gradient. What you're going to need for this is a piece of scrap paper. I'm using a giant one because I'm working on the board, but all you'll need is like loose leaf. You'll need a pencil and you'll need a calculator. So again, gradient or just math generally in this class is going to be either some type of subtraction with division or some type of division. In this case, it is going to be subtraction and then division. All right, so gradient formula is the change in field value. All field value is referring to is the change in elevation, in this case for our class. But it could also be like air pressure, it could be a change in temperature. So gradient is not just an elevation thing, which is why we have field value and not change in elevation. But in this case, yes, we're talking about an elevation. And that's going to be divided by the distance between the two objects. All right, so let's do a little recap, little review of what we've talked about before. We'll bring it back. So just a little review. Wherever the sea or the ocean touches land, this elevation here is 0 because everything is based off of what we call sea level. So if this is 0 and we have 100 here, we need to find the contour interval on these maps in order to do a lot of these questions. So like if let's say the question asks, what's the elevation of D? Well, we don't know what these lines are unless we do a guessing check. So usually to find the contour interval, we're going to use the numbers 5. So like going up by 5, 10, 15, right? We can use 10, we can use 20, 50, and 100. Those are the usual ones, but that doesn't mean that sometimes we're not going to have a contour interval of 2, contour interval of 1,000. I'm just saying those are the ones you should usually go off. So let's do a guessing check. We know sea level is 0. We know this level is 100. Let's try 5s. So 0, 5, 10, 15, 20, 25. Nope, that's not 25. Let's try 10s. This is 0. So then 10, 20, 30, 40, 50. Nope. Let's try 20s. 0, 20, 40, 60, 80, 100. So the contour interval goes by 20s. So the elevation of D, which is one line above sea level, right? So if we follow along, that's one line above sea level. That is going to be an elevation of 20. If it was on the next line up, that'd be an elevation of 40. And if it was between those two, we can write any number between 21 and 39 because it's not on the 20 line, so it's got to be a little more than 20. But it's not quite yet up to the 40 line, so it's got to be less than 40. But you can really use any number between there, but let's just say that it's a little closer to the 20 line, maybe write 25. If it's a little closer to the 40 line, maybe write 35. And if it's right between, choose the number right between. It's probably the best way to do it. Use your best judgment. All right? So final thing to review is the rule of V's. So if they ever ask you, what's the compass direction that a stream flows and how did the contour lines help you with that? Well, you always start by saying V's point uphill. So we look at the creek here, Mud Creek, which direction does that flow and how do you know? The V's point uphill. So that means that the stream is going to be flowing this compass direction. Remember, a compass direction is like north, south, east, west, right? So in this case, it's not south or east, but it's a combination. It's southeast. So you would answer the V's point uphill, the stream or the creek flows southeast. Why is that? The V's are pointing northwest, so the opposite direction is southeast, which is the direction it flows. Also, it just flows downhill, right? And this is the ocean, this is the top of a hill, so it should make sense. Okay. So let's try an actual gradient question. So just to review gradient again, get to it. Gradient is the change in field value, in this case elevation, divided by the distance between the two locations. Let's get into a good practice problem with that. So let's try to find the gradient between letters A and C. So here is A, here is C. We need to find out what the contour interval is. So we're going to look at the numbers that they give us. Here's a 50 on a line, right? Here's a 75 on a line. So let's try our rule, right? So like 5s or maybe 10s or 20s. So 50, we're going to go by 5s. 55, 60, 65, 70, 75. Turns out the contour interval is 5. And sometimes on the map, it'll even say it. Elevation is in feet. The contour interval, which is just what the lines go up by, is 5 feet. So we're doing A to C. So we start by finding the change in field value, which just means the number that belongs, or the number that the letter sits on, right? So A is on the 50, 55, the 60 line. So A is on the 60 line. All right. And C is on, I'm not sure. So here's the 50 line, right? Here's the 50 line. 50, 55, 60, 65. C is on the 65 line, okay? So that means there's going to be a change, you may be able to guess, from A to C, a change in elevation of 5. But we're not done. We need to now divide by the distance between between A and C. So this is where our scrap paper comes in, and that's where our little key comes in on the bottom. All right, so we're gonna just line up our paper. I'll do it sideways. We're gonna line up our paper so that both of the dots, A and C, are being touched. And I'm just going to lightly mark them, right, as accurate to the dot as possible. Not to the letter, but to the dot that belongs to the letter. And now I have these 2 dots on there. I take these 2 dots, I mark one of the dots up with 0. I'm gonna actually turn it like this. I mark one of the dots with 0, and then we look across and ooh, there's our other dot. That is about 1.0, but to be exact, we're gonna go by, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So we're gonna call that about 0.98 is the distance, 0.98 miles. So it's just under 1 mile between letter C and letter A. So if we do 65 minus 60, that's gonna give us 5, and this is in feet. 5 feet divided by 0.98 miles. So now we just go to our calculator and we plug that in. 5 feet divided by 0.98 miles. 5 feet divided by 0.98 miles. Right, so we can go back. 5 feet divided by 0.98 miles, or you could do 0.98 miles. And that gives us just about 5.1. So that means every mile we travel between A and C is going to rise 5 feet, or just about 5 feet. So let's do another example, maybe a little harder, a little more difficult. So let's try letter F to B, okay? F to B. Find the gradient between F and B. So we start by finding the value that the letter is sitting on, right? So here's 50, and when we go towards the 75 here, we're counting up by 5, right? Each line goes up by 5. But since F is on the other side, we need to go down by 5. So F's value is going to be 45. 45. And B is going to be, so it's on the inside, so 50, 55, 60, 65. B is going to be an elevation of 65. And this is in feet again. Now we need to divide by the distance between F and B. So I'll take my scrap paper, I'll line it up with the dot for B, I'll line the other side up with the dot for F, and I'll just lightly mark them. Nice. There we go. That's going to be our distance. Just going to line up this first little mark with 0, and then this is going to be the distance, just about 1.1, 1.2, 1.3, a little bit less than 1.4. We'll call it 1.38. 1.38 miles. So we're just going to have 65 minus 45, which is 20 feet, divided by 1.38 miles. All right? So remember, this is measuring steepness. So So if we have 20 divided by 1.38 miles, we're going to end up with 14.49. 14.49. And that's going to be from F to B. And just a reminder, from A to C, the gradient was 5.1. All right. So, where would you want to walk? Would you want to walk from A to C where the steepness is 5 feet per mile, meaning that you go up 5 feet every mile that you walk? Or would you want to walk from F to B where you have to go up 14 feet in elevation for every mile you walk? I'll tell you this, I want to walk from A to C because it's not as steep. It's not as difficult to climb. F to B is much more steep, so it's going to be a lot more difficult to climb. Plus, it's a little further anyway. So that is the intro to gradient. Good luck, and I'll catch you on the flip side.